Okay, so this is another question that I got from somebody in my email of how to find all the second order partial derivatives of this function w equals 7x squared tangent of x to the 7y. Now this is a kind of complicated problem because we might have to use chain rule, we might have to use product rule. It depends on what we're doing. So our goal is to find w sub xx, w sub xy, w sub y, and w sub y x. So these are the second order partial derivatives of the function w. Okay, so as I mentioned in the last video, when you take a partial derivative, you hold all the other variables as numbers and you take the derivative like those guys were just straight numbers. Okay, so now I'm going to start with w sub y first, just because that's a little bit simpler partial derivative. So in order to get wyy and wyx, we're going to start with w sub y. So w sub y is going to be the partial derivative of the function with respect to y. And that means x is a constant value. We're going to treat x like a number. So w sub y will be, this 7x squared is just a number. It's a coefficient, so it's going to come down. And now the derivative of tangent is secant squared. So secant squared of x7y. But since x7y is not just y, we have to then also multiply by the partial derivative of the inside. This is chain rule. So we're thinking, what is the derivative of x7y with respect to y? So that means all the x's are constant. So my x to the 7th just comes out as a constant, and I need to do the derivative of y with respect to y, which is just 1. So for chain rule, I'm going to times this guy by x to the 7th. Now let's do the second part. Oh, there's no second term. Sorry. We got the whole term here. So the partial derivative with respect to y is 7x to the 9 secant squared of x to the 7th y, and we're done. So now if we want w sub y, we're going to do this same process with w sub y, and we're doing this process with respect to y again. So w sub y, we're going to take w sub y and we're going to hold x as a constant and take the derivative. So 7x to the 9th is going to come straight down because it's a coefficient on this guy. So now we have to think about the derivative of this guy. So this is secant of something raised to the 2nd power. So I'll bring the power down, 2, and then the secant technically to the 1st, right? I'm just using the power rule, x to the 7th y. But now, since the thing that was taken to a power, right, we can think of this as u equals secant of x7y, we just did the derivative of u squared, which goes into 2u to the first, but then we have to times by u prime. So we're going to have to do u prime for this guy. So the derivative of secant is secant tangent, but now, since it wasn't just secant of y, then we'll have to take its derivative of the inside with respect to y. So again, that was this purple one, taking the derivative of x7y with respect to y is just x7. So on this term here, I'm going to tack on secant x7y tangent x7y and then an x7. Now I've done all my calculus. Now I'm just going to do algebra. So let's see. Not inside of a secant, I've got a 7x9, a 2, and an x7. So that makes 14, and then x to the 16th. And now I've got a secant of something times secant of that same thing. So that's secant squared of x7y, and then tangent of x7y. So this is w sub y. It's the second derivative, or second order partial derivative of w with respect to y and then with respect to y again. So now let's do w sub yx. So w sub yx is going to take the partial derivative with respect to x of the partial derivative with respect to y. So we're taking this black, so I'm going to just write it here so you can see it. 7x9 secant squared x7y. So now when I take the derivative of this with respect to x, you'll notice that this is an x thing and this is an x thing. So we're actually multiplying two things which have x as its independent variable, which means we're going to have to use the product rule. So I'm going to come over here and I'm going to say my f is 7x to the 9, and my g is secant squared of x7y. So now f prime, again, we're taking this with respect to x, would be 63x to the 8th. But now g prime, like before, we're going to have to use the power rule and then the chain rule and then the chain rule again. So the better you get, the less you write, but you can write as much as you need to. So for this guy, my u is secant of x7y, and I've got u squared. So when I take that derivative, it's 2u times u prime. So I'm going to start there. I'm going to do 2 secant of x7y. So now I have to figure out u prime. So what's the derivative of secant? It's secant tangent. So secant x7y tangent x7y. But it wasn't just x in there, it was x7y. So we have to think about the partial derivative of x7y with respect to x. So the y is going to come out like a constant, and then the derivative of x to the 7 is 7x to the 6th. So I would tack on here 7 x to the 6th y, and I'll clean it up now, and I'll call this 14 x to the 6th y secant of x to the 7th y. So now we'll use our product rule. So f prime g plus g prime f. All right, so we're just about at our w sub y x. F prime g, so that would be 63 x to the 8th times secant squared of x to the 7th y plus g prime f. So 14 x to the 6th y secant of x to the 7th y times 7x to the 9. So on the first term, there's nothing to clean up, so I'll just keep that as 63x to the 8th secant squared x to the 7th y plus, now I have to do 14x to the 6th y times 7x to the 9th. So 14 times 7 is 70 plus 48, so 118. 118 x to the 15th y secant of x to the 7th y. So this is my w sub y x. Now I have to start back again all the way at the beginning with w to get my w sub xx and my w sub xy. So I'm going to rewrite the problem and then I'll zoom in. So I've got w equals 7x squared tangent of x to the 7th y. Okay, so now we want w sub xx and we want w sub xy. Both of these start by taking the partial derivative with respect to x. Now, excuse me, similarly to what we just did, this has two pieces, right? This is a function of x, and this is a function of x. So we're going to use the product rule. So my f is 7x squared, and the derivative of f with respect to x is 14x. And then my g will be tangent of x7y. So now g prime, and again, that's with respect to x here. Y is held as a constant. We're going to do the derivative of tangent is secant squared. And now we have to find the derivative of x7y with respect to x, which I think we did back here. Yep, up here in purple, so I'll just rewrite it. The derivative with respect to x of x7y, we keep the y, and then we times by the derivative of x to the 7, which is 7x to the 6th. So for my g prime, I need 7x to the 6th times y. All right, so now we've got to do our f prime g plus g prime f. So w sub x will be 14x times tangent of x to the 7th y plus, and then g prime f. So 7x squared, that's my f, and then my g prime was 7x to the 6th y and then secant squared of x to the 7th y. And I can clean it up a little bit, but I've done all my calculus. So I've got 14x tangent of x to the 7th y plus, let's see, 7 times 7 is 49. X to the 2 plus 6 is 8, and then y, secant squared of x to the 7th y. So this is my first partial derivative with respect to x, and I'm going to use this two ways. I'm going to take the partial derivative of this guy with respect to x again, which is called w sub xx, second order partial derivative, first with respect to x, second with respect to x again, and w sub xy, so that's a second order partial derivative, first with respect to x, then with respect to y. So let's do it. So for w sub xx, we're taking the derivative with respect to x of 14x tangent of x to the 7th y plus 49x to the 8th y secant squared of x to the 7th y. Now this is going to be a lot of bookkeeping. The derivatives, the calculus is not the tough part here. The tough part is going to be bookkeeping this guy. So let's look at this first part here. Since we're going with respect to x, we've got two x functions times together. We're going to have to use the product rule. So we'll make our f 14x. So our f prime is just 14. And then my g is tangent of x to the 7th y, and my g prime is the derivative of tangent is secant squared. So secant squared x to the 7th y. But since that wasn't just x in this case, we'll have to take the derivative of x to the 7th y with respect to x. So that gives us y times 7x to the 6th again. So 7x to the 6th y. Okay, so for the first term, we're using product rule f prime g plus g prime f. So I've got w sub xx equals, all right, f prime g is 14 tangent of x to the 7th y plus g prime f, so that's 14x times 7x to the 6th y times secant squared of x to the 7th y. Now we need the second part. I'm trying to get like a unique color over here. So now we have to do the derivative of this guy. And again, with respect to x, these are two separate functions. This is my f function and my g function. So if my f function is 49x to the 8th y, and we want the prime of that, we're basically taking that with respect to x. So y is held as a constant. So you've got 49y, and then you want to times that by 8x to the 7th, just a regular power derivative. So now 49 times 8 is what, 396? So this is 396 x to the 7th y. And then my g function is secant squared of x to the 7th y. So now again, this is a power rule. Okay, this is my u equal to secant of x to the 7y. And my du, or my u prime, is secant x to the 7th y tangent x to the 7th y. And since it wasn't just an x in there, we have to times by the derivative of x to the 7th y with respect to x. So that, like normal, would become 7x to the 6th y. So now my g prime will be, like we're thinking about it, as u squared. So the derivative is 2u to the first and then du, or u prime. So we would have 2 secant of x to the 7th y times u prime, which was secant x7y tangent x7y, and then 7x6y. And the only things we could even kind of put together are the 2 and the 7x6y. So the g prime that I'm going to use is 14 x to the 6th y secant squared of x to the 7th y, right? Secant times secant, and then times tangent of x to the 7th y. So all that work, and we still need to do f prime g plus g prime f. So I'll go back to pink because I'm finishing up this derivative. So this would be plus f prime g, which is 396 x to the 7th y, times secant squared x to the 7th y plus g prime f. So I'll put the f first. That was 49 x to the 8th y times 14 x to the 6th y secant squared of x to the 7th y times tangent x to the 7th y. And again, that's very long, but we've done all of our calculus. Now we're just doing algebra, which is generally the hardest part. So let's look at this first term. That guy doesn't have anything to put together, so we'll just keep it. 14 tangent of x to the 7th y. So I'm basically trying to clean up each term and then see if I can combine any terms. Okay, so now this second term, 14 times 7, that was 70 plus 32. Oh, 7 times 4, sorry, 28. So 70 plus 28 is 98. So 98 x to the 7th y secant squared of x to the 7th y plus this guy, that doesn't have anything to clean up, 396 x to the 7th y secant squared of x to the 7th y plus, and now I have to do 49 times 14. I'm going to use a calculator. I'm sure I'm messing up this multiplication. 49 times 14, 686. Okay, 686 x to the 14 y squared secant squared of x to the 7th y times tangent of x to the 7th y. Now the only two things that we can combine are these middle terms here, because they both have secant squared of the same thing, and they both have coefficients that we could actually put together, right? Like we can actually add 98x7y plus 396x7y. So for my final answer, I've got 14 tangent of x to the 7th y plus, let's see, 396 plus 98, 494, x to the 7th y secant squared of x to the 7th y plus, and then the last term, so 686 x to the 14th y squared secant squared x to the 7th y times tangent x to the 7th y. And I know like the second two terms both have secant squared, but we can't combine their coefficients nicely. And the first and last term both have tangent, but we can't combine their coefficients nicely. So this would be w sub xx. Now for w sub xy, that's going to be the partial derivative with respect to y of the original wx derivative, right? So this would be the partial with respect to y of 14 tangent x to the 7th y plus 49 x to the 8th y secant squared x to the 7th y. Now if we're going to do this, which we actually aren't, and I'm going to show you why, but if we were going to do this, this guy is just one function, so we just bring down the 14 times the derivative of tangent, which is secant squared, and then times the derivative of x to the 7th y with respect to y, which is x to the 7th. But then this guy, so this is just kind of like regular chain rule. But then this second term, because the coefficient has a y in it, this is another product rule. And the g part is going to be, again, a chain rule upon chain rule. Now, why am I not doing this? Well, it turns out that wxy is exactly the same as wyx. So we already did wyx here. And so that should be what I get when I do this derivative. So your choice is to do the derivative to double check, or in this case, like if you've already typed in one of your second derivatives and gotten it correct in MATLAB, not one of your second derivatives, but one of your mixed second derivatives. So if you already typed in your wyx and you got it correct, then you could just retype it for wxy. Alternatively, when it's, a smaller derivative, I would say go ahead and try to do it again just to double check yourself. But in this case, I mean, we've basically spent 30 minutes on the first 3 second order partial derivatives. Like, let's save ourselves the 12 minutes of doing this 4th second order mixed partial derivative.